welcome everybody to the fall 2020 virtual TWed end of term lightning talks. Yay. This is amazing. So the rules are very, very simple. You have about 2 minutes. We're not going to make a big deal. If it's short, if you go long, we'll all start making weird noises at you. And you just talk about whatever you want to talk about. Most people have selected something related to their research topics. Logistics, we are recording this. People actually like this recording because it's a great summary of the work that's going on across the tetherless world. It's a real fun time. I encourage everybody to have your video on. It looks like, I think most people do have the video on. And I would encourage you at the end of each person's time, please give them the same kind of appreciation that you'd like them to give you. And without further ado, let's kick it off. We'll go in the order that people signed up. So that would be alphabetically first. Ahmed, hit it.
Thanks, John. Hello, everyone. I hope you're all staying warm today. So I'd like to tell you a little bit about what I've been working on recently. I've been working with network and graph embedding methods to come up with solutions to some of the main problems in the projects that I've worked on throughout the past few years, specifically to do with natural systems, things like data sets like mineral co-occurrence, fossil co-occurrence as well as other data sets of genomic data from samples, so microbial communities, and then along with the mineralogy or the geochemistry of the location. And so data sets at different scales. What I'm doing is trying to, using network embeddings, come up with graph representations for these data sets, because usually the information is more rich in the relationships between all the entities than in the properties or attributes of every particular entity. And so it's really the interconnections between these entities in these data sets where the information is. So I'm trying to use really all the leading graph network embedding methods and to evaluate them on some common predictive analysis tasks to do with these data sets, like mineral classification, or like, for example, identifying communities or clusters within the entire fossil network of a lot of interacting fossil families of different organisms, and so on, with the objective of taking the best performing, which is at this point is the deep learning approach to come up with representations, and enhance that by using some graph entropy measures to perform even better. Yeah, so that's it.
All right. Normally, we'd have you go up to the whiteboard and cross off your name.
Crossed off.
All right, Anirudh, go ahead. Kick it off.
Everyone, again, my name is Anirudh, for those who don't know me. Some of you might have seen on the topic that I signed up for, it's the formalism to partition knowledge graphs into knowledge networks. And as I was thinking this morning about how I'm going to talk about this, I realized I can't really talk about the formalism without sharing my screen. So instead, I thought I'll talk about how I actually got to this topic, how this actually emerged, and then also mention that I'm presenting the same topic in 2 days' time at AGU, and that poster will be published. And so for those who are actually interested in the real formalism, I'll put up the DOI somewhere, on Twitter or on the TW site or something. So this kind of goes back to January of this year, a long time ago, before, we were actually allowed to go out of our houses and stuff. But Peter and I were at the ESIP winter conference, and we had presented this 2-part talk at a open knowledge networks session. And, Peter talked about what are open knowledge networks and how they're useful. And I talked about how does one gain insights from them. And I kind of used a lot of the examples of, converting the data behind a knowledge graph into a network object, and sort of apply similar things to what you guys have been hearing me talk about for a while now, which is the network analysis, network science, etc. So when I kind of talked about it, a lot of people liked it, etc., etc. But like a few people approached us and kind of asked, "Is there a formalism for this? Can we generalize this? Is there like a way for us to take all of our knowledge graphs and convert it into these, network objects?" Because we really want to do this too. And if there's a formalism, if there's a thing that you can write up that we can cite and follow, that'd be great. So, uh, like that evening, Peter and I met and we kind of discussed some ideas, and we agreed to go back to our hotel rooms and just scribble some stuff and put some stuff together, and then come back and discuss it. So those scribblings, those discussions are essentially what started off this formalism. And we got like an initial idea for a generalized logical formalism, mathematical formalism to to look at the data, the SPO, the triple data, one property at a time, and then extract the data and format it into a network data object. So that's kind of how we got here and created this formalism. If you want more details, please talk to me. Also, the DOI for the AGU presentation will be out like after Friday after I present. So I'll post the DOI somewhere and you can look at the actual poster. We're also writing up a paper on this, like a technical report. So either ways, there'll be a lot of updates coming up. So that's about it. Thank you.
Very cool. Thank you. And I'm going to keep after you for that link. All right, Brenda, I don't want to go first.
Well, hey everyone. First of all, congratulations on being here, and if you're able to extend that to actually participating in this round of TWed Lightning Talks, congratulations. So let's face it, we've just worked through a semester controlled by a pandemic, an unprecedented life event for all of us. So just, be gentle with yourself.
Can you come off of video? Can you turn on your video?
Believe it or not, I actually don't connect my video to anything. I'm still the
Okay.
performance.
Go ahead. I'm sorry to interrupt you.
So anyway, so I'm Brenda Thompson, a third-year multidisciplinary science PhD under Dr. Fox. These lightning talks are supposed to be summaries of our current research work. And originally I was going to talk about my attempts this semester to master web development using Drupal. And Drupal is an open source content management system that's been used as a backbone for science websites like deepcarbon.net. However, I worked as a TA this semester for Comp Sci 1, which made Drupal far heavier to pick up than I anticipated. So I would like to share a little bit of how my own research time and TA time came to overlap. So initially, I wondered how the semester would unfold for a class of undergrads who are experiencing their first semester of college in a pandemic, without realizing that how the lessons that they needed to learn would also help me help myself. So basically the semester and the research that I was able to do was a lot of ups and downs and frustrations for them, the students, as well as for me. I spent more than my allotted time assisting the students assigned to me with things like navigating RPI, where to go for additional assistance, how to succeed in college, and simply communicating, trying to get to connect with their own classmates. And it took a lot of energy. Actually, pretty much everything this semester took a lot of time as well as energy. So anyway, for my own work in creating the cyber infrastructure for some larger research projects here at RPI, using Drupal actually kind of became a stumbling block to my own success, simply because the demands of learning a new content management system takes time and focus. And so just like the students I was TAing, I was trying to learn a language, a new format, some rules, all while needing to meet goals and deadlines. And basically I spent far too many hours sitting and staring at a screen, frustrated by, how much time Zoom and WebEx and Slack took, but, I managed. And all of this while I heard myself calmly encouraging my students to be gentle with themselves, to protect their study and work time, to set up templates to simplify their work, and so on. And it took me a while to understand that I needed to wind up spending the equivalent amount of time implementing those behaviors for myself. So ultimately, my own heavy lift of learning and implementing Drupal came down to just squeezing a few items out of my head and onto paper, into templates, and onto the websites. All of this while hearing the students exclaim, it feels like I didn't get anything accomplished, but I sure was busy. And that being said, look for an announcement soon about some amazing new websites. And thank you, everyone. Finish what you can and be gentle with yourself.
Hopefully you weren't using the TW portal as a learning example code.
No, thank goodness.
But hopefully you were using the DCO portal as an example. Anyway, Fifi, it's your turn. Go for it. Oh, is Fifi on? I don't think she's on.
No.
She signed up next.
She must have thought, I think it's at 6 because typically we used to have TWeds at 6, right?
Yeah, that's why I send out 14 emails that say it's at 5. All right, so Jay, you're next.
Yep. Yeah, sure. So I was going to talk about the study cohort extraction work that I've been doing. So this started with Shruti recruiting me as a URP to work on it because Shruti was doing a great job on her study cohort ontology for categorizing the different kinds of characteristics that you tend to see in clinical trial tables as they describe the patient populations. And she recruited me and she gave me a bunch of PDFs and told me, okay, turn these into knowledge graphs. Turn them into study cohort ontology knowledge graphs. That's what I've been chipping away at for the past year or so. And I've settled on a system which is a 4-step pipeline system where we take the PDF, we extract out the kind of tabular information, and then we use a couple of different heuristics to look at the specifics of the table. So the first thing we do is we look at, okay, we have a table, where is the indentation in the table? And since study cohort tables can have a whole lot of indentation and rows nested underneath other rows, we kind of use that structure to say, okay, well, this row has, 3 different sub-rows, and then they have their own sub-rows, and that kind of structure is actually a connected graph in of itself, right? Or is a kind of a graph in of itself of different layers of tables. And so we extracted that out, and using that kind of graph structure, we were able to turn that into a knowledge graph just by identifying from the text, well, okay, specific elements of a knowledge graph are kind of found in the table, and how do they relate to each other? How does the study cohort ontology say that they should relate to each other? And how can we put it all together? And in particular, in the past little while, I've been looking at, okay, if there's a biomedical term, how do we turn that into a knowledge graph concept or an ontology concept? And I've been using the NCBO annotator for that, which if there's anyone here doing biomedical kinds of stuff, I can't express as much anymore how helpful the NCBO annotator is for that kind of thing, which allows you to just given a specific piece of text, you can annotate it with all of the biomedical terms and whatnot that it corresponds to. So I don't know, it's a really neat tool. It's on BioPortal, and I've been using that to basically, given these PDFs, generate this graph-like structure, and then going in and filling in all the details.
Thanks, Jay. I almost blew the horn, the timeout horn. You quit just in time. All right.
API, right, Jay? They also have a BioPortal API.
Hey, no follow-ups.
Okay, cool.
Top Lightning Talk. Lightning Talk rules.
I
know it's tempting. Shruti, it's your turn now. Go for it.
Yeah. Hi, everyone. So basically, I'll try to keep it short. I spoke to you all the last time about basically about the fact that we started a new work stream, particularly focusing on explainability. Within the work stream, actually, we had a couple of, I would say, actually, we had a couple of milestones the past year. Firstly, we conducted. Firstly, we published. Firstly, we pub. Firstly, we pub. Firstly, we pub. Firstly, we pub. Firstly, we published 2 book chapters. Mainly on the foundations of, and also and all and all and also and all and also the directions for, and also the directions, and also and also the and also and also and also the directions for explainable knowledge enabled systems. Post that we conducted we conducted a user study with clinicians. Um, 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 Vetting the explanation types we had found from the literature. After that, after that, we decided to work on a formalism. Stealing the word from Anirudh, a formalism for explanations. Modeling specifically, I would say. Modeling specifically, I would say. Modeling specifically, I would say. Modeling specifically, I would say the system user, as well as I would say the, as well as I would say the, as well as I would say the system user interface attributes related to explanations. We actually won the best paper award for that work at ISWIC this year, and that was according to me the kind of like a, I would term it as like a highlight for me this year, in this year, which is so challenging. That was nice for us. Currently now we're looking at currently now we're looking at currently now we're trying to work on a service a service to be able to map the recommendations from methods to be able to map the recommendations from to be able to map the recommendations to be able to map the recommendations from to be able to map the recommendations from sorry to be able to map the recommendations from AI methods into explanations into explanations into explanation into explanation into explanation into explanations which into explanations which into explanations into explanations which can be addressed into explanations which into explanations which into explanations into explanations addressing user questions. That's about my work, I guess. And then personally, I find myself being more empathetic this year. I've learned to be more calm, and then because of that, I found the pandemic a lot more challenging initially, but then basically now it's become, like, I would say, okay to be able to speak during Zoom sessions, as is for all of us Zoom and WebEx sessions. And I'm just hoping for all this to be done soon, and to see you all in person. And with that, I'll just say that stay safe, happy holidays, and stay healthy. Thank you.
All right. Thank you, Shruti. All right, Matt.
Hello, everybody. I'm going to talk about automating semantic data dictionary creation and kind of the progress we've made this year. So STDs, if you don't know them, they're kind of a key component in a lot of our projects here. They basically describe tabular data using ontological terms and can even be used to generate knowledge graphs doing that. Currently, to generate them, though, you need to be not only skilled in ontological modeling, but also have a working knowledge of the domain, which often doesn't meet together. And so we are developing several tools, a UI to help build them, and also a suggestion service algorithm to provide suggestions throughout. One of the key components in this is the attribute suggestions. So basically, given a data dictionary description of a column, so something like participant ID, we want to link that to the attribute that's closest in the ontologies that we're given. So we might want Haskell original ID or something like that. And so originally we took a parsing tree methodology where we would take the descriptions and we would break them down to their components, their sentence structure, and try to use heuristics to identify which is that attribute. And for the first few studies that worked pretty good, but as we got more and more data in, we found that there is a lot of variety in the way people describe columns and define terms within a data dictionary. And so we've moved on to a machine learning model, a transformer network, where we basically use the attention mechanisms built into this network to pay attention to keywords and find better mappings. And overall, this new methodology has proven better. I think we've improved by about 20% in our suggestions. But there's some drawbacks to models like this. First, in order to improve this further, we need access to more data. And we're trying to address that now. And first way we do is we talk to people and gather. So I guess a quick advertisement. If you've got STDs lying around, send them my way. The other big one, though, is we're looking at using other data out there. There is a competition called SunTab. I think it's annual now. But basically, they have a similar task, except without data dictionaries. And we're looking at artificially generating data dictionaries from ground truth to further train these models. So future work, we hope to improve performance there even further, and then also extend this to other fields in semantic data dictionaries, and hopefully enable non-experts to more easily generate knowledge graphs that the world can interact with. And I think that's my lightning talk.
All right. Thank you, Matt.
Thank you
very much. Okay, Shweta. Is Shweta on?
Yep.
All right. Go for it.
So, hello, everybody. I hope everybody's doing good today. I'm going to talk about data rescue with you guys. Not sure if the whole lab is familiar with the concept. I think as Peter's group, this is probably a third or fourth project that I've been working on. You can think of data rescue as recovery or rescuing of data from, say, old journals or old PDF files, or handwritten notes from scientists that are just shelled into filing boxes and that do not reach out to everybody for their research. Especially given how much we are talking for open data or fair data, this has come onto the forefront of projects that we are doing with different domains. One such effort that we are doing is with prebiotic chemistry. It's in collaboration with Dr. Karen Rogers, who leads the Rare Center up here at RPI. And through data rescue, you get to learn a lot of new things. We've been doing this over the summer now. We were engaged in this activity where we have the entire research group, whether it's professors, PhD students, undergrads, all working together, reading papers, like about 150 of them, which we had curated. And we're trying to extrapolate the data from these papers. There's figures and also graphs and charts and tables, but also data sets that were just in the literature and not in form of the formats that we as computer scientists or data scientists are used to working with. So through this process, we are trying to work with the domain scientists to understand what is important, what is not, at the same time collaborate with them and truly do a multidisciplinary project where both skill sets are non-negotiable. You can't really do without the other. And through this entire project, eventually we will get to research and analysis. If you guys remember Fong, he did a great project like this. Even Howe had done with I think it was in the Deep Carbon Observatory, and to some extent, even I think Anirudh's minerals Gemi project does tend to do that to some extent. So that's all about data rescue, and that's my time, I guess. Thank you.
Thank you. All right, Sola.
Right, yeah, so what I'll be talking about today is kind of more on the future research direction that I'm kind of hoping to follow. So around this time last year, for people who remember, I kind of was talking about work involving ingredient substitution in recipes, and how I was looking into trying to substitute ingredients for reasons like, say, you want to make a recipe healthier and you want to reduce the carbs, so you replace your potatoes with cauliflower, or you're eating a meal with someone who's allergic to something, and so you need to replace some other ingredient to make it so that that allergen is no longer in the recipe. Well, the higher level goal of those kind of substitutions really was focused on that aspect of health. How can I make this meal healthier for me? And if we kind of take a step back, really, then we also need to consider some aspects of context regarding what actually is healthier. Include the context of yourself. So say any sort of diagnoses you have, or particular allergy you have and whatnot, or the context of who you're eating with or where you're eating. Say if you're eating by yourself, this particular change to a recipe might make it healthy. But if you're eating with a friend who has a different type of medical problem or diagnosis, then that change might not really be healthy for them. And so you might need to kind of reconsider what sort of changes you're making. And so moving forward, the direction that I'm trying to take is kind of to consider context awareness in terms of kind of personal context as context of the particular domain, the context of what goal you're trying to achieve. So for the running example, say the context of trying to improve your personal health, and then providing some sort of recommendations based on that, including recommendations for, say, individual changes, like, say, substituting an ingredient, or maybe also recommendations for like larger plans of things, like, say, a meal plan that is healthy for your particular context, for your particular dietary goals. And to work towards this, I've kind of been trying to use some work that I did in a class. I'm taking the ontology, or I was taking the ontology engineering class with Sabira this term, and so I kind of was trying to apply this to kind of the context of recommending courses to university students and using that sort of context. And also for the funded research that I'm doing, trying to do more of recommendations for people to make their diets healthier and such. So yeah, that about wraps it up for me. Thank you.
All right, thank you, Sola. Kara, I think you're next.
All right, hello everybody. I'm Kara. I am a newly minted PhD who has been working with Jim Hendler. So this will be my last TWed Lightning Talk. And today I'm going to be briefly talking about what my thesis work was. Thank you. So my thesis was entitled Exploring Discrimination with Artificial Life, and I decided to work towards my very long-term goal of trying to figure out some of the genetic and social factors that feed into negative human social discrimination. Obviously, that's a really broad topic, so I narrowed it down to a simple form of discrimination that we see both in humans and in many other members of the animal kingdom, which is how similar you and your potential mate are on some sort of physical trait or genetic trait, or in humans, even some sort of social trait. For example, in America, people tend to marry those who have a similar educational background to themselves and are less likely to marry somebody who has a very dissimilar educational level. So that's something that we see very broadly, both in humans and animals. And in my artificial life simulation, I replicated that by adding a genetic factor that makes mates more or less preferable depending on how physically similar they are to that agent. So I wanted to see if I could manipulate the evolution of this factor. Could I make it evolve towards preferring more similar or less similar mates with a genetic and an environmental factor? The genetic factor I chose was genetic disorders, and the environmental factor was the level of migration between two populations that were otherwise separate. What I was expecting was that with my two levels of genetic disorders, the higher level would lead to agents performing less similar mates because that would make their children more likely to not have a genetic disorder, which is very bad and life-limiting. And with my two levels of migration, what I expected was that the higher level of migration would lead to agents performing more similar mates because then their mate would be more likely to be adapted to their specific environment. What I found was I did find effects of both migration and genetic disorders. It was only not quite what I expected. So both the higher migration level and both the higher level of genetic disorders led to agents preferring more similar mates. So I'm still trying to figure out exactly what was happening in those populations, but I did find an effect, and I think this shows the usefulness of this approach.
All right, very cool. Could you post somewhere, maybe you could just email me. You must have some papers that you've written. Is your dissertation minted, or are you still refining it?
I'm sorry?
Is your dissertation available, or are you still refining it, to get signed up?
I don't know if it's available via RPI yet because it just got approved today, but I can send it to you if you want.
Just today, exciting. That's fantastic. Yeah, I would love to. The agent stuff is agent-based simulation and stuff is really fascinating to me. I just would love to learn more. All right. Sabira, go for it.
Hi, everyone. I'm Sabira Rashid. I've been part of TWC for like the last 4.5 years or so. I'm working with Deborah McGinnis. I'm recently a PhD candidate with her. So today I actually wanted to take this opportunity to not talk about my research or any funded work I'm doing or anything like that, but more so a idea, I guess, or like what really got me interested in ontologies in the first place. So, so the title of this TWed talk, I guess, is Visions of a Semantic World. So, in the world we live in, there's a lot of there's people, places, and things essentially, right? And but that list of things is very huge. There's like organizations, there's processes, events, languages, um, you name it. And like in terms of people, people themselves have a lot of attributes. They're humans, and maybe they have some identifier pointing to them. So actually, for a lot of the things I'm talking about, I want you guys to think about, oh, is there an ontology that exists to describe this thing that you've seen before? Or, oh, I've never thought of making an ontology for that specific thing. So like people, for example, have contact information, right? So they have an email address or a phone number, and there's like a name, and that name itself can have a lot of different parts. They might have a social security number, a driver's license. Maybe there's some demographic associated with that person, right? So they're a certain number of years old, or they may have a biological sex or a preferred sex, or maybe they're married, maybe they're from a certain country, what's their nationality or ethnicity or race. Maybe they follow a certain set of beliefs, and so on and so forth. Like, where do they live? There's a physical address associated with that location, which has a house. And inside that house, there's a lot of things like there's a lamp in that house, or a television, or a stove. And you can go on in different directions. Maybe they work at a certain store or an organization, right? So that organization itself has a address and like has all these products, and maybe they have a employee, or maybe it's a research organization that's sponsored. And then you can also think about like events that the people are involved in. So like this person was born on a certain date to these parents. So what else is in this person's house, right? So maybe there's an instrument in the house. So what's an instrument? Well, I see the guitar over there, or maybe they have a piano. Is it a keyboard, a grand piano? Maybe they play some woodwind instruments like a saxophone or a oboe or a clarinet. Maybe they have a library in their house with a bookshelf filled with books. What's inside those books? Oh, it's a math book, or there's a physics book, or it's a story book. And there's like all these things in the world which themselves, everything's all connected to each other, but it's so full of information. And the people in the world are like part of a society which has a culture associated with it, or politics or religion. So pretty much where I'm getting at is the world itself is very semantic and everything's connected together, but you don't really see a underlying ontology connecting all these things, but these individual things themselves could have ontologies on their own, right? So I guess what I'm envisioning is this kind of like semantic world where everything within itself can be connected to itself. But what I also want to be able to do with this underlying ontology or knowledge representation is to also visualize it, kind of like the simulation Kara was talking about, where like, okay, now I'm in this virtual world where I'm driving a car down a highway on a certain geographical location and so on and so forth that I can actually see. Maybe I can use it to predict trends in the stock market. Maybe I can make a movie with this kind of simulation. Maybe I can make a video game. Maybe I can use it for education, so I don't know. I'm just imagining visions of a semantic world.
All right. All right. Thank you, sir. Jason.
Hello, everyone. I'm Jason. So I'm working with Professor Deborah McGinnis as a PhD student. So today I'm gonna talk about something related to common sense reasoning. This is part of our machine common sense project. So common sense reasoning is actually some knowledge that people will not state it explicitly in everyday conversation or in the test. So it's very because people knows common sense, but machines will not. It will be very challenging for machines to understand common sense as well. So the goal of the whole project is to develop some approach or test the ability of the machine to see whether they can handle common sense. So at the beginning of the project, a number of very challenging data sets was proposed to test this kind, to test such capability of the machine. But unfortunately, as the with the development of a very large pre-trained language model like BERT's Robota, the machine can achieve near human beings' performance on those benchmark data sets. And all those benchmark data set is multiple choice questions. So after people is trying to propose some generation-based questions, like given a few words, like describing a specific scenario, and the machine will be asked to generate a fluent natural language sentence to describe those the scenario using those provided words. So it's and also the machine are asked to answer some questions regarding numerical reasoning, which is some drawbacks of existing pre-trained language model. One data set that we are tackling recently is a question developed by a company called Psych. So the goal of this data set is to test the machine about their ability to answer some entangled question, such as the first true or false question sounds like a fish can ride a bicycle. And the second question is whether aquatic organisms don't have enough eggs to ride a bicycle. So so people assume that if the machine really has common sense, they should be able to answer these two questions correctly at the same time if they actually can handle the background knowledge properly. So all these things is very challenging and interesting, and I think it's necessary to be appropriately solved before we can achieve the general artificial intelligence. So that's it. Thank you.
Pretty big stuff. Thank you very much, Jason. General artificial intelligence, yeah. Mitchell, go for it.
Can you hear?
Yeah, we can hear you pretty well.
So I guess I'll just start off by saying, so I'm Mitchell. I'm a co-term master's student with Deborah, and I've been working with Enrique on basically extending the work of what the DSA policy builder did. So as a little background, the DSA project brought to life a separate tool for building dynamic spectrum allocation policies that are semantics based. So one of the benefits of semantics based policies is that you can reason over them, and you can apply logic, so it can be read by a computer and operated on by a computer, whereas a lot of policy language is often just a formal structured language, but it's not machine readable. So that's just like a brief overview. And so the idea is, for my research, and this is going into my master's thesis, is it's a domain agnostic version of this. So we have the dynamic spectrum version of this. Well, my version is going to be a domain agnostic version, which can be used in many different scenarios. And so currently I've been working on it for the past I guess 2 semesters now, because we're reaching the end of this one. And so what I'm doing, what I've got working is I've got the policy construction done, where you can actually specify the attributes and all of the individual pieces of the policy using the language that was set out and based on XACML and that in the DSA project, using all of that as a basis for creating a domain agnostic version. And the domain agnostic version is going to be, like, the idea is to make it capable of editing and creating policies as well as viewing them, and just make it overall easier to use semantics-based policies for other applications. So one of the applications that beyond DSA would be an application like, for instance, like network access. You can restrict network access. You can, like, any permissions-based structure works well, but then there's also like other operations like healthcare recommendations was one of them. So if anything you can foresee where it's a sort of like you have like a functional, like, I have this set of properties and only these requests can be fulfilled, or these requests correspond to an output, then you can make a policy that's really built on that. So yeah.
All right. Oh, so yeah.
Yeah.
So yeah. So Mitchell, I asked in the chat, but I'd like very much to get a demo.
I actually had it running on the other screen.
Yeah, no. I mean,
But,
no.
This is not the time
for it. It would be
for it.
something other than a lightning talk if you were to proceed onto the demo.
Yeah. I'd love to give a demo.
Yeah. So I'd like to get you and Enrique together, because I'm sure there's questions I'm going to be asking that Enrique would answer and you might not be able to answer, but I'd like to attack it and really get into it when it is convenient for you guys. All right. So thank you for that, Mitchell.
Thank you.
And Ishida.
Hello. Can you hear me? Hello?
Perfectly.
Oh, okay, good. So hi, for those of you who don't know me, my name is Ishida. I'm one of Deborah's master students as well. So this semester, I have been working on generating explanations for food recommendation systems. This work is kind of an extension of Shruti's explanation ontology work, where Shruti's work derived and formalized certain types of explanations using a clinical use case. I am working on extending that into the food domain so that we can provide explanations for users for users of food recommendation systems. So this semester specifically, I have been working on a couple different types of explanations. Shruti's original list had 9. I'm working on only 3 of them: contextual, contrapositive, and contrastive. Sorry, I think I misnamed one of those, but anyways.
It's fine.
Yeah, counterfactual. Been staring at the screen too long. But anyways, yeah, so I've been working on formalizing those in a food domain specific way. For example, if we look at counterfactual, contrastive explanations, we would have 2 parameters, for example, 2 different types of food, and we would want to find different facts and foils, facts that would support a food or support a recommendation, and foils that would suggest that we wouldn't want to go with that food. So how do we formalize that and how do we formalize that logic in a food specific domain? That's what I've been working on. The way I went about doing that is an interesting mix of just of the ontology itself, as well as putting a lot of logic and inference into the ontology. My current model abstracts out some of the parts extracts out some of the lower level food characteristics, abstracts out some of the lower level food characteristics, such as something that a user might like, or where food would be available, into these larger ecosystem and user characteristics, which I then infer on to get specific explanations. Next semester, I want to extend this work into different explanation types, specifically scientific and statistical, and possibly add some of this work into a knowledge graph. Yep, that's it.
All right. Now we have a number of other people, and we still have some time. We've got about 9 minutes left in the hour. Are there any staff type people who would like to jump in and say something? We all have meetings all day long, so our brains are burnt out. Well, I'll jump in and do a little bit. As some of you know, I've had the pleasure, I guess you'd call it, of working with an army of undergraduate students since the spring. developing a whole set of different data analytics applications that deal with COVID. Some of them are visualization and data exploration. Some are related to predictive modeling of the spread in different localities and in specifically in different kinds of schools. And some of them were tied into reopening of campus in a couple different ways, and monitoring and helping campus administration and actually students help with the de-densification of the campus. And with this term, we've come to a point where we've got I think we've got 5 or 6 different applications that we've gone live with. Some of you have seen COVIDminder. That was the thing we started the year with, which takes daily downloads of data from Johns Hopkins and a number of other sources and plots national trends, state trends, county trends, and does determinant analysis, social determinant analysis as well. There are 2 apps that were originally conceived of by Malik Magnan Ishmael, and have been converted to web-based apps, interactive apps, including COVID Back to School, which was used by the administration in helping to make decisions on reopening campus, but it's been made a public app that any school that from primary schools to colleges can utilize for modeling at different situations, social distancing, turning different dials. And then there's Safe Campus and Study Safe, which use aggregate Wi-Fi data to help understand what's going on campus and in different situations. Study Safe is really cool because it was conceived of this summer by a student and it's in testing right now. We're going through some user testing with it, but that enables near real-time decision making on where's a good place to study based on what Tuesdays at midday are like, et cetera, et cetera. And it's got all of these have maps in them, and all of these have different kinds of analytics and predictive modeling. So it's been a real long year. I'm sick and freaking tired of COVID and COVID data and plotting COVID. And it's just going to continue, but I wanted to just really praise the students that we've been working with in the IDEA Data Insight program this year, who have done some real hard work, put some long hours in to create some cool apps that are doing some good. And that's my piece.
I have a question. I was wondering how difficult is the data cleaning process from Johns Hopkins website?
So that's interesting. So we have found, based on our testing, that the JHU data is pretty good. We've only had a couple situations this year. Well, first I should say there's a couple different kinds of Johns Hopkins data that we get. There's different streams. You get time series data and some other data. We have found at least 2 occasions where unannounced they changed the name, they changed the column, or they changed this, or they changed the format, which interrupts our pipeline, which we have to jump in and fix. So we have to, there's a daily process of making sure things work fine. It's semi-automated. In terms of the completeness of the data, that is, we do have to keep an eye on that. Our code has to be very tolerant of missingness. In some cases, it just doesn't matter. Since some of the stuff we're doing is like daily updates, it kind of doesn't matter. We do daily polls, and sometimes it's self-correcting. You know, early in the pandemic, New York would move around mortality. Deaths would switch from one county to another county. In the net, that was not a problem because we would always do fresh data. So But it is an issue, and also there's a lot of data that's missing. Where there really a lot of data about demographics, racial, data tied to race, data tied to other socioeconomic stuff. This is really important to understand the social determinants of health, and a lot of the United States, particularly in the localities that need that data the most, they're doing the poorest job logging that data. That's not a Johns Hopkins issue. That's kind of a general data collection issue with COVID. Anyways, that's been one of the issues. But anyways, it's a good question. We should be careful not diving in on the lightning talks. So anybody else want to say something?
Yeah, I'm gonna say something.
Yeah.
So I've been working on a side project for a couple of months now. So this geographical reasoning has been following me my whole life. So I did a little bit of my master's, I did a little bit of my PhD, and I did a lot on the essay as well. So I started to create for now as very minimalist front end for enabling some geographical functions in an easy way. We have Geosparkle, but not every triple store enables it. Jenna does a little bit of it, and we have a new paper, not we, but there is a new paper on Newsweek this year presenting Geosparkle Plus. There is also a new work group working on new iteration of Geosparkle. So I started to create this front end for enabling easy geo calculation over geographical data, of course. And so far it's very incipient, but I'm slowly working on that because I think it would be useful for us and for the community in the future. So yeah, that's just to say that I'm working on that.
Sounds like a good side project, Enrique.
Yeah.
All right, anybody else? Deb, would you like to finish up the hour here? Deb, put down that glass of wine.
Okay, can you hear me now?
Yes, we can.
Okay, good. Yeah, no wine, only coffee.
Oh.
So far. But the wine cellar actually works again. It broke, of course.
Oh no! Oh.
It works again. The cooler's installed and it's cooling again. So the world is good. Yeah, I just I've been in a PI meeting, a National Institute of Health PI meeting today, which was like really fascinating and totally motivates our work. We were all talking about combinability of data and all the challenges with that and how much precision you need. And actually, we had epidemiologists and toxicologists basically saying they can't really do their work without us. So super cool. That's on the work side. But on the bigger picture side, I just wanted to express my appreciation and on behalf of, all the faculty and senior staff at Tetherless and IDEA, we really appreciate what you're doing. This has just been, a year. One of my Facebook friends said she just celebrated her birthday and she said, I want a do-over. I don't want 2020. I don't want this to count. So, I think we all need to be creative about ways to find joy and balance and be productive and be taking care of ourselves. And so I just wanted to express my thanks because, normally we would have a party and that's harder to do. And normally we would be, having some food. And I tried to find out whether there was any way I could have food. And I got no, and no. So anyway, there's not much we can do that we would typically do. So I just want to say a heartfelt thanks. And, we really appreciate you, and none of us could do this alone. We really are in this together, both to get through COVID together, but also to get through our teamwork together. So thanks.
Together apart.
Yeah.
Distance makes the heart grow fonder, right? All right, let's everybody give themselves rousing. And I'm not sure who was just talking. Ahmed, was that you? Your network is really bad.
I want to know how Sabir and Shruti and Mitchell are doing these funky little things with their pictures.
Yeah, I want to know.
So next to share, there's this reactions button. You guys see that?
Oh, even the Linux thing
how
has
cute.
it.
Thank you.
I think that's new. I didn't notice
that
that
appeared
before.
like today, I think.
I'm surprised the
and there's a wine
Linux
bottle.
thing has it. They like almost never update stuff.
Really, this is, except, I don't know, does it show me doing mine?
Yeah.
Yeah,
you do.
we see you.
Yeah, we see your bubbles.
Top in the quirk.
Okay, cool. Anyways, with that, oh, that does it in our little pictures. Like, that's very cool. Let's schedule another meeting just so we can play with this. All right. So thank you, everybody. And take care of yourselves. This is the last. Sorry, Ahmed, you keep trying to say something. I can't hear it.
If you turn your, sorry. Go ahead, Ahmed. Sorry.
The earphones are not working. I just wanted to tell everyone that SpaceX just completed their Starship hop test. You should all go and watch it. It's just amazing.
Well, the other thing that happened this hour was NASA announced the 18 Artemis astronauts. Those are the astronauts that are going on the Artemis project to the moon, and 9 of them are women.
Yay!
So NASA has finally decided that they should send the smartest people in the world to the moon. With that, have a great one,
All of
everybody.
us can say, well, it's about time.
It's about frickin' time. All right. So there will be a recording of this posted in the usual channels when WebEx finally compiles it and all that kind of stuff. So anyways, take care, everybody. Thank you very much.